Hello everyone! For our math performance task, we conduct a survey among 15 students from Assumption College of Davao, collecting data on both their age and weight. Our objective is to analyze the correlation between these two variables and provide an interpretation of the results. By examining the relationship between age and weight within this specific group.
What is correlation?
Correlation is a statistical measure that expresses the extent to which two variables are linearly related.
And this is an example.
So this is a table of age and weight among the senior high school students of ECD that we conducted a survey yesterday. And this is a table of correlation. So first x, second y, third x squared, next y squared, and last is xy. So our x is the value of age and our y is the value of weight. To get the value of x squared, we need to multiply the value of x by itself. So 60 times 16 is equal to 256, and 17 times 17 is equal to 289. Okay, thank you. Same process to get the y squared. We need to multiply the value of y by itself. So 54 times 54 is equal to 2916. Next is 50 times 50 is equal to 25. To get the value of xy, we need to multiply the value of x and y. So 16 times 54 is equal to 864. And 17 times 50 is equal to 850. And next is 17 times 54. Summation of x, we need to add the value of x. So the summation of x is equal to 257. Same process to get the summation of y is we need to add all the value of y. So the answer is 845. So the summation of x squared is 4417. The summation of y squared is equal to 49497. The summation of xy is equal to 14,507. The value of n is equal to 15.
So we have here the given formula of correlation. So we have the R equals N times the summation of x and y minus x, the summation of x times summation of y, over the square root of N, the summation of x squared minus summation x squared, and N, summation of y squared minus summation of y squared. So that's the formula to find the correlation.
So we already know the formula of correlation, and we already get the simulation value of correlation table. So now let's solve. R is equals to 50, which is the number of our n, and times the summation of xy, which is 14,507, minus the summation of x, which is 257, over square root of number of n, which is 15, times the summation of x squared, which is the 4417, summation of x, which is 257, and then the value of n, which is 15, and the value of y squared, which is 49497, minus the value of xy, simulation of xy, which is 845 squared. Next is we need to multiply the 15 times 14,507, which is equal to 217,605, minus the summation of x and y, which is 417,165, over square root of. Next, we need to multiply the 15 times 417, which is equal to 66,255, minus 257 raised to the power of 2, which is equals to 66,049. And after that, we also multiply the 15 times 49,497 is equal to 742,455, minus the 845 raised to the power of 2, which is 714,025. We need to subtract the 217,605 minus 217,165 is equal to 440, over the square root of. Next, we need to subtract this one, which is the 66,255 minus 66,049 is equal to 206. And then, next, subtract this one, which is 742,455 minus 714,025 is equal to 28,430. That we need to copy this one and over square root. After that, we need to multiply this one, which is 206 times 28,430 is equal to 5,856,508. After that, copy the 440 and get the square root of 5,856,580, and which is equal to 2,420.03719. And after that, we need to divide this one, which is equivalent of 0.1818537. After that, our final answer is equal to 0.18.
After surveying 15 students from Assumption College of Davao and collecting data on their age and weight, we calculated a correlation coefficient of 0.18. This figure indicates a very weak positive correlation between age and weight among the students. In simple terms, as the student age increases within the range of 16 to 20 years old, there is a slight tendency for their weights to also increase. But this relationship is minimal and not significant. It's worth noting that the age range and weight range of the students survey varied from 16 to 20 years old and 41 to 87 kilograms respectively. However, despite of the broad range of data, the correlation remains weak, suggesting that other factors beyond just age and weight contribute significantly to the students' weight variation.